All right, our third graph, y equals x cubed. Again, let's get some axes. Let's draw a few tick marks on the x-axis. And I'm just going to label these points and not label my y-axis. So let's plug in 0. 0 cubed is 0. Boom. So I get that point right there. 1 cubed is 1. So I'll get a point right there at 1, 1. I have my 0, 0. What about 2? 2 cubed is 8. 2 times 2 times 2 is 8. And 3 cubed is like already crazy big. 3 cubed is 27. 3 times 3 is 9. Times 3 is 27. Well, what about negative x values? Here, if I plug in negative 1, I get negative 1 times negative 1 times negative 1 is negative 1. So I get that point right there at negative 1, negative 1. And then I plug in negative 2, and I get negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So I get this point right here at negative 2, negative 8. And then I plug in negative 3, and I get negative 3 times negative 3 is positive 9, times negative 3 is negative 27. And I get this point right here at negative 3, negative 27. So my graph looks something like that. Whereas the farther I go to the right from this middle point, the more quickly I'm growing. So my graph is getting steeper and steeper and steeper. But I can plug in whatever x value I want, and I can always cube it. So my domain is going to be just all real numbers. X in the set of real numbers. In interval notation, just saying x is in the set from negative infinity up to infinity. And it's going to be the same thing with my range. I can get any output from this function. And so y is going to be in the set of real numbers. And just like x, we'll say y is in the set from negative infinity to positive infinity. And there you have it. But notice the symmetry.